This is a continuation of the Chapter 7 practice. Dealing with question number 3, showing why a pair of functions are inverse functions. So remember, if they are inverse functions, they will undo each other. So we need to show that g of h of x equals x, and also that h of g of x will equal x. All right, so we're doing composition, and this means we're going to put h of x into g of x, so h of x into g, which would give me 3 times x minus 4 over 3 plus 4. The 3's would cancel. I've got x minus 4 plus 4. The minus 4 and plus 4 would cancel, and it does equal x. I also have to show it the other way, so putting g into h, I would have 3x plus 4 minus 4 all over 3. The plus 4 and minus 4's would cancel, and then 3x divided by 3. The 3's cancel and we get x. So therefore, yes, they are inverses. If either of these do not equal x, then they are not inverses. Next, we're going to graph functions stating the domain and range, and these are radicals. So remember that a typical square root graph has a general shape of this, and our typical movement is over 1 up 1, over 3 up 1, over 5 up 1. So for number 4, we are going to move right 3 and up 4. Right 3 and up 4. Remember, if it's in the square root sign, it's opposite of what you think. And then what I would do is write out the general movement of a square root function. And then negative 2, since it's out in front, we'll multiply the y's by negative 2, because that will vertically stretch or shrink the graph. Then my movement is over 1, down 2, and then over 3, down 2, and the graph would look like this. Domain of this is the x. So as you can see on the x-axis, the entire graph is when x is greater than or equal to 3. Range is what y can be, and as you can see looking on the y-axis, looking up and down, the highest point of the graph is at y equals 4 and below, so it'd be y is less than or equal to 4 would be your range. Number 5, this graph is moved left 1 and down 2. That's our beginning point. And then again, this is our general movements. The 3 out in front is going to multiply the y's by 3. So I'm going to go over 1 and up 3. I'm going to go over 3 and up 3. And therefore, our domain would be x is greater than or equal to negative 1. Our range would be y is greater than or equal to a negative 2. Just seeing where these graphs are at. All right, inequalities is the same type of thing. We're just going to graph it, and then the big thing is going to be if it is less than or greater than, we know it's going to be dashed. If it's equal to, we know it's going to be solid. If y is by itself, less than would mean below, greater than would mean above. So for number 6 here, we've got a graph that we're going to move right 1, up 3. Here's our general movement. That 2 is going to double the y's. So I'm going to go over 1 and up 2, over 3 and up 2. And then I look at the sign as less than. It's not equal to, so it's dashed. It's less than, we're going to shade below the graph. Number 7, I'm just going to change a little bit here. Under the square root sign, I'm going to divide this by 2. So we've got a fraction underneath that square root sign. Okay, so how this affects it, we're still going to make our movements. So we're still going to move left 2 and up 1. And then my general movement here, the negative 3, again multiplies the y's by negative 3. Since I'm dividing 2 under the square root sign, I'm going to double these x's. So now I'm going over 2 and down 3. And then over 6 and down 3. This graph's going to be solid because it's equal to. And we're going to shade above the graph. Next problem, we're going to be simplifying radicals. So remember, in any type of radical equation, if we're going to simplify it, we're going to break it into things we can do, things we can simplify, and things we cannot. If there's no root here, we assume this to be a square root. So we're looking for a perfect square factor of 50. The largest perfect square factor is 25. That's something we can simplify, and 25 times 2 is 50. Since I'm doing square root of the variables, anything with an even power I could do. So I can do x to the 4th. I cannot do y to the 5th, but I could do y to the 4th, leaving a y in what I cannot simplify. And then I simplify the beginning part, and I leave the square root the same. Okay, as another example here, let's say I don't have a square root. Let's say I'm doing a cube root of, for example, let's say 54 x to the 6th, y to the 11th. So again, I'll break it up in the same way. Now I'm doing with cube roots. So I'm looking for a perfect cube factor of 54. So thinking perfect cubes, I have 1, 8 does not go into 54, 27, 3 cubed does. So I have 27 and 2. Cube root, so my powers need to be multiples of 3. So I can do x to the 6th. I can't do y to the 11th, but I could do up to y to the 9th, which would leave y squared as something I cannot simplify. Then simplifying what I can do, 3 is the cube root of 27. Dividing those, 6 divided by 3 is 2, 9 divided by 3 is 3. And then I leave the cube root. Number 7, we multiply. We're multiplying radicals, so it would be 12 times the root of 12. Got to make sure that this is simplified as far as we can. We break this up into do's and don'ts again. I could do root 4. So now it's 12 times 2 times the root of 3, which would be 24 root 3. Number 8 here, we are adding and subtracting radicals. So the only thing we can do here is combine like radicals. For example, let's say 3 root 5 plus 6 root 5 is 9 root 5. The radicals are not the same, you can't combine. So these are obviously not like radicals, but each of these could be simplified. Root of 50, I could break into root 25 and root 2. which is 5 root 2. 32 I could break into 16 and 2, so that'd be 4 root 2. 54 I could break into, I think 9 goes into 54 6 times. That'd be 3 root 6. And then you can see I've got some like terms here. 5 root 2 minus 4 root 2 is 1 root 2, or root 2. And then I have the 3 root 6. So when you have radicals and you're adding and subtracting, just combine those that are alike. Number 9, we're multiplying an expression involving radicals. I can FOIL. So 2 times 4 is 8. 2 times a negative 3 root 2 would be a negative 6 root 2. Negative root 2 times 4 would be a negative 4 root 2. And then I have a negative times a negative, so a positive 3 root 4, which is 2, so positive 3 times 2 is 6. I can combine like terms. I've got 14. I'm going to minus 10 root 2.